So I just have these little plastic test tubes that have the gradations on them so that I can see what I'm doing. And I keep everything clean in between viewings. So these have little screw-on caps, which is great because then I can keep my samples organized, I can label them. I just bought some glass microscope slides off the internet from a company I would not recommend because they all came like stuck together and I had to take a razor blade and like separate them all and then clean them again. And then I get 18 by 18 cover glass. And the size of the cover glass really only starts to matter if you're gonna be quantifying because you have to do all the math to say, okay, I have this one drop of soil, but I need to be able to do the math to extrapolate to what's going on in general. So you wanna make sure you have constants, basically. And so we use 18 by 18 for that purpose. And we reuse this stuff. So we only have a couple boxes of each thing. I'll sit there and carefully and laboriously wash off all of my slides and all my cover glass.
With alcohol or just water?
Chlorinated water will kill most, yeah. So I live in the city of Asheville, so no problem there. I
aerate mine before I ever use it for stuff like that.
Really? I mean, I always dried really, really well, and then, if I'm worried about it, there are like chem wipes you can use for like getting it really nice and clean and before you stick it under there. So yeah. When you put who's got soil? Can I use that one? Where's this from?
My perennial garden.
Oh, okay.
Yeah, don't get too excited.
Oh, I'm excited. I'm always excited.
I bought some biodynamic soil from a local place.
Okay.
It's out in the car, so I forgot I even had it, but I've got
Okay.
a half truck full of that.
Cool. Well, I usually use like some kind of stainless, like 1/8 of a teaspoon or something scoop is really good. This is a 1/4 teaspoon, and you want to fill it up with soil to about 1 milliliter. So like halfway up here. I think it's actually the bend is 1 in this tube. And if you everybody knows how to take a representative soil sample, right? Yeah. Like you don't just go out into your 5-acre pasture and take one plug and be like, here you go, lab, here you go, Meredith, sample this. You need a zigzag and get a representative, mix it all together, and then pull from that. So if your sample's not mixed up well, you may want to take a little dip from one side of the baggie, a little dip from another side, a little dip from the other side, and put that in. But this looks pretty uniform, so I'm just gonna scoop it out. This can get a little, your little area will probably get kind of messy. So you can see it's right up to that little bend right there. And then I have distilled water or spring water, so non-chlorinated basically, in this spray. And I'm gonna fill it up to the 5 milliliter mark. So this is what's creating a 1 in 5 dilution. This is where we always start. So that you can see bigger things like microarthropods if they are there, or nematodes if they are there. And then if you get into the business of quantifying and counting bacteria, which is like the worst part of this, you have to really dilute in order to get, so you'll want to start at 1 in 5 to count all the other guys first, and then dilute pretty heavily until there's, I think Elaine says, like 30 to 50 bacteria in your field of view. Yeah, so it's 1 in 1,000 sometimes by the time you're ready to count. And so a lot of folks that I've worked with who've graduated from like microbiology master's programs would take this and like literally shake the smithereens out of it. But Elaine says to be gentle. So this is what she recommends, is sort of like the elbow up and down for 30 seconds.
Because you might be killing things?
You just don't want to you want to mix it, but you don't want to blow up all the fungal hyphae and you don't want to scare all the protozoa, right? So just the gentlest mixing we can manage, because we still want to be able to see. A lot of the people that I've worked with were used to a vacuum process where they were shaking it up and mixing it, and then they were actually oil immersion microscopy, and they were vacuuming all the water out of the samples. They're killing everything anyway, you know what I mean? These things, they're like you and me. If you smashed me and sucked all the water out of me, I would die, right? So these little critters are not much different. So the reason that Elaine's methodology is what it is that we're looking at these things in real time, right? We're looking at them in the water, alive, moving around. And that's why you don't have to have a super powerful microscope. That's why these are generally kind of affordable. It's like $200-300 to get a scope with a camera that goes up to 400x magnification. And that's I would like to have at least 100x just so that I could see a little bit more, but she says it's not necessary. If the water's still in the organisms, then you can see everybody at 400x that you need to see. Once I have mixed, I have these little plastic pipettes that I get online. And I'm going to get everything ready. It's usually helpful to have like a little cup. So I usually keep a little cup of water, chlorinated water for cleaning my pipettes between samples. And then I keep an empty cup for dump water. And then I'll have a cup where I can stash my tools in or my sample bottles in. So you just kind of want to have your little thing organized before you start. And so then you'll want to get your slide ready. And obviously you want it to be clean. I usually keep like a little bit of, those like little chamois claws that you get with your sunglasses. I'll keep one. I'm just gonna use my dress right now. But you can kind of wipe it off, just make sure when you look through it, it doesn't have your big old fat fingerprint on it or something. And then get your cover glass ready. And sometimes these little critters.
You have to move fast?
Well, you don't have to move super fast. I don't want to stress out, because then I usually just knock things over. So these little things are very breakable and very small and very hard to see. So I usually get one ready, and then I'll put it on the stage of my microscope because it's black there and I can see it very easily sitting on there, and then I'm ready to put it down. It's important to remember though, like when you're washing, how many of these you've used, because they're very easy to lose. And then if they break on your kitchen floor and you come in tomorrow morning barefoot for your coffee, and ouch. A lot of people use plastic, but I find that they scratch and kind of dull, and you can't use them as much as long as the glass ones. So I'm just going to leave it right there on the stage of my scope. So pipette, squeeze to create suction, let go to draw things into it. We're going way back to like middle school chemistry here. And so I usually if some time has lapsed between when I did my gentle mixing, then I'll come in with my pipette and sort of squeeze and release just to mix it up a little bit more. And then, uniformity is great. If you're doing a bunch of samples, you want to go the same. You want to let the soil sample rest the same amount of time. You want to mix it the same amount, and you want to kind of sample in the same way. But you're looking for one drop. So I just want to pull a plug out, and then you can see I'm dropping out any air bubbles. And then I'm just going to come and I'm going to put one drop on my slide. And some people like 2 drops, some people like 3 drops. If you're doing the math, you just have to remember how many drops you did, and you have to do the same number of drops every time so that you're quantifying properly. And I'll usually label this like masking tape or a grease pencil or something so I can remember what I've done. So I'll take my cover slip and I'll just take the very edge of it and kind of spread that drop out gently, and then drop it on. All right, so now you're ready to put it on the scope. Quick terminology, this is the stage. This guy moves the stage up and down. There's one on each side, so if you're left-handed. This is the coarse focus, this is the fine focus. These are the objective lenses. We always start at the smallest one, which is 4x. The eyepieces have a 10x magnification, so you always multiply 10 times the objective lens magnification. So if we have 4x here and 10x here, we're at 40x magnification. The highest is going to be my 40x objective lens times 10 gives me 400x magnification. Scopes are built differently, but they almost always have some kind of clip for putting the slide onto the stage. And then over on this right side, there's two scopes that are identical here, and then this other one is an Imax Trinocular scope. It works the same way, but you'll just have to futz with the controls. There's a light adjustment here, so you can adjust how much light's coming through the condenser by adjusting this knob. There's the on-off switch. And then under the stage, there's gonna be this little tool called the iris diaphragm, and you'll use it back and forth with the light adjustment to create shadowing behind the organisms. A lot of times you won't be able to see flagella, or you won't be able to see cell walls, or you won't be able to focus properly if you don't have shadowing going on. And you'll have to play with it and just learn what works best for you. It'll work differently depending on, like if you have really red soil, for example, or really dark soil, or based on how your eyes work. So you'll have to play around with it. Also, the eyepieces, you'll have to focus them for your eyes. We don't want to smack our eyeballs onto the scope. We want to be floating a little bit. And some scopes, only one of the eyepieces will have a focus on it. So you want to focus the other eye first by closing the eye that's focusing on the one with an adjustment, getting everything looking pretty good, and then opening the eye and using the adjustment. There's also this tool right here that allows you to move the eyepieces closer together, farther apart, depending on how your face is built. And so you'll have to obviously get your sample into focus before you can even do any of this. So what I usually do is move the stage all the way up make sure you're at 40x with the smallest objective lens. If you have the 40x lens and you start moving that stage up, you're gonna crash into your objective lens and get everything dirty and break cover slips and stuff like that. So we always start at 10x. So I start all the way up, and then I just slowly, using the coarse focus, will move down until I can see the critters.
You guys running this straight through photo booth?
Mm-hmm.
Really?
On a Mac, that's the way to do it with these scopes. On the PC, you have to install the software. So I'm using this iris diaphragm. Do you see the difference? Oh, it's all the way open here, and I'm closing it. It's gonna be hard for me to do this with you guys watching, because like right now it's in focus for me. It's not for you. So if I want you to see it, I have to play with it by looking at the screen. At 10x, I usually just do a scan. So you can see the edge of the cover slip there. This little knob under the stage, the big one is gonna move you up and down, and the little one's gonna move you left to right. So you'll just sort of scroll, and you'll note things. You're like, oh, I wonder if that's a fungi right there. Like, we might want to come back to that. But what we're looking for at this quick scan is nematodes, microarthropods, and larger organisms.
Are the chunks we're seeing aggregates?
Mostly aggregates, yeah. I'm willing to bet. I mean, sometimes you'll zoom in on a chunk like that, and it'll end up being like an egg sac or a mass of disease-causing fungal spores, or, I mean, anything. But for the most part, they look tattered and ragged like organic material. That's my air bubble. Or one of them. So I don't see any like crazy critters right off the bat, nematodes. When you're looking at the scope, this will be better.
You're scanning on 10?
It's on 10 right now, I'm just scanning on 10. Looking at the screen instead of the scope is really weird. I'm like super disoriented right now.
It's all backwards too.
Mm-hmm. And depending on the type of scope you have, like this trinocular scope, the camera attaches to the top and it moves around. So you'll be like looking at something right side up, but on your screen, when you want to take a video or a picture, it's going to be upside down. So So that's really fun too. I usually go top to bottom from left to right. Looking. We definitely have bacteria, I would say.
So I found that, yeah, if you do it the same way every time, it's a lot easier to go back and find
Yes,
what you were looking
what you're looking for. Fairly unexciting scan.
Like I said, it's super, super dense clay.
Is
with
it?
Some organic matter that we just started 2 years ago, so.
Okay, let's start zooming in. And these lenses, if you buy a microscope, they should be what they call parfocal, which means if you're focused at one objective, you should be able to switch and still be pretty close in focus to where you're just using the fine. And if they're not, you should call the company and say, hey, my 10x lens is not parfocal with my other lenses and I need a replacement. I had to do that once and they were fine about it. So now we're at 10x objective lens times 10, we're at 100x magnification. I find that I don't often use the 10x and the 20x objective lenses. I go do my scan at 10x and then I just bump up to 400x and just start looking more closely. But I do want to show you quickly the difference. Sometimes if I have something big in my field of view, I'll back up to 200x to take a photo, but otherwise we're using 40x objective to look at things. So here is, hey everybody.
More interesting.
Here is my 200. I'm just going to try to shadow it a little bit differently for y'all and see if it... Now you're seeing some guys moving around. Always kind of exciting. If you're looking at something moving, know that as you follow it, focusing differently and also shadowing differently will help you see it in more detail. But it's kind of like driving a car, you know, you have to teach your brain how to move the stage and focus and change the iris all at once. So you see things moving in one direction there, that's the water moving. And since I got some air pockets in my droplet, it's gonna be doing that a lot. This probably isn't the best sample, but don't attribute that to the organisms having motility, right? That's the water moving them, so. But I mean, let's just look really fast. Like we're at 400x now. So little guys like this that you see moving around, these are absolutely bacteria. If they're flipping around, we might have a flagellate right there. I see it, it looks a little bit bigger and it's kind of bumbling about, but with the shadowing the way it is, it's very hard for me to tell. We may have some like cysts, see those there? That looks like maybe a spore sprouting or something, but it does actually look like it's moving a little bit. So if it was an encysted protozoa is not gonna move. It's gonna be just floating.
How do you know it's not a small air pocket? They're not.
Well, you would see internal, first of all, you can see a cell membrane pretty discernibly on cysts, not in this picture because our focus is pretty bad, but you can also focus in and out. And if the air pockets will be kind of dark all the way through, you know, whereas like you'll be able to see, I guess, dimension to the organisms, and you'll also sometimes see internal organs. So you can kind of tell a difference. One thing you definitely will mistake is you'll mistake clay particles for bacteria, and that's just sort of assumed that it's gonna happen because they're relatively similar in size. And what I see is a lot of bacteria. I see some protozoa. I see protozoal cysts. There seems to be a decent diversity of bacteria. There's good aggregation. There's silica crystals. There's humic acids. So far, haven't seen any fungus. If you scan around, at 400x, you could be scanning forever, because on an 18 by 18 cover slip, there's 20 fields on the cover slip, and that's if you're turning your stage once up or down. You should be able to rotate 20 fields of view, and that's what we use when we're quantifying and counting. So I might, if this was a really good focus and really good shadowing, I might spend some time with that guy, look at it. Is this a fragment of a fungal hyphae, or is it something else? Typically, fungus doesn't make like a 90-degree turn like that. So unless it was getting ready to branch and it broke on both sides, it's likely not a fungus. But if I do see septi, as I focus in, then yeah, maybe it's a little fragment. And I do see septia, so I'm kind of confused. It also could be a piece of something else that had a fungal hypha growing out of it. And so I'm seeing that straight piece is a fungal hypha, but the little knob thing at the end is not. As you're pulling with your pipette from your sample, you don't want to be pulling big chunks of things in general. So it's going to be rare. You may run across a root hair every once in a while, and it's going to look humongous, on there, but you're generally not going to be seeing roots. Amazing. It's like super well shadowed for me under the scope. Scanning some more. I see a lot of mineral components. I see a lot of sand. Oh, interesting. You see that little thin guy? I'm wondering if that's an oomycete. And then the guy at the end of it almost looks like an amoebe. I don't know what's happening there. I think he's just in front of it or something. So this is obviously like a decently aerobic soil. You've got good aggregation, you've got bacteria, and you've got bacterial predators. You've got some fungal fragments, but you don't have really high numbers of fungi in here. That looks like a fungus. You guys see that? You see the septae? So that's decent. It's a little on the thin side, but it's dark and it has uniform septae, so we can surmise that it's not a harmful fungus. So that's good. Elaine says that we should, if we're doing really well, if we're killing it, as we say, there will be a fungal hyphae in every field of view, which we certainly don't have here. And that we should have one nematode per slide. So we really want to be favoring higher taxonomic groups, basically. Here's some more interesting stuff. You guys see that? That looks like a fungal hypha there. Branching. It's hard for me to see. You'll have to focus because, they'll be tilted in the soil solution. So if I focus one way, I can see the branch more clearly. If I focus the other way, I can see the other end more clearly. But you want to focus along the entire length of the hypha in order to sort of make sure it is indeed a hypha, to make sure, oh, look at this good fungus here.
Those are non-septate.
They can have septae, but the septae will be irregular.
If you see a lot of non-septate or
That's no good, yeah. It's getting anaerobic or they're pathogenic. So this is hard for me to see. I can tell it has a little bit of a darker color. I can't really see the septa. The way it's growing makes me think it's a fungus though. And under the scope I'm seeing septae. So this is actually good. This is looking good. Look at that one. Or wait, that's the one we just looked at. Who's this? You guys see that thin one? Yeah, light colored, really skinny. Not so great. The question is, who's going to win, in this ecosystem? Is it, like you said, it's a really dense clay, so that may be where some of these anaerobes are coming from, right? So if you, don't be stomping around there with your boots on. In other words, you want to be creating conditions in which the aerobic organisms will win out over the anaerobic organisms. And this is I saw a couple of mineral particles in here, but I don't imagine you're adding a lot of highly concentrated amendments or anything, right? Yeah.
And I haven't done anything since early last year.
Great. So yeah, this is what I'm talking about when I say qualitative. We're just kind of scanning through, we're taking a look. We're not counting fields, we're not worried about how many we have, we're not worried about our fungal to bacterial ratio. We're just taking a look and saying, oh, I have a general idea of what's going on in this soil now. Maybe some, ooh, hi. Where was that? There's a thing to your left that's kind of snaking around that I can't. I think it's a flagellate. God, I wish I could focus better for you guys so you could see it. But you're going to see. You're going to see soon through the scopes what I'm talking about. Oh, the other thing you'll see is algae. This might be one. Do you see that one there? That long oblong thing on the right? It might not be an algae. Usually with algae, you'll see pigmentation inside, so you'll see greens or blues or bronzes. So it could be a mineral part, it could be a piece of mineral. Would it be that big? A chloroplast be that big?
No, that's what it is. Pigment.
Yeah, the pigments. But I see a good diversity of bacteria. I see rods, and I see cocci, and I see long rods, and I see short rods, and I see diplococci. I see pediococci, which are sort of long, but they're fatter than the rods are. So yeah, if you were to throw down a dime-sized layer of some really awesome fungal compost on this bad boy and keep it aerated, I think that'd be awesome.
You're saying the thicker double walls of the amoeba?
Or the amoeba, yeah. And I still have a hard time because in class the other day, Elaine showed this picture of this huge brown fuzzy thing that I would have been oh, it's an egg sac or something. And she said it was an amoeba that was turned on its butt. So you weren't looking at the lateral view of it. It was upside down. And I would have never guessed it was an amoeba, So it's hard, with the protozoa for sure, especially when they're insisted to sort of feel competent. But if you see,
Does that happen when they go anaerobic?
it can happen when they go anaerobic, but it will also happen just when they get shaken or disturbed. So you would be looking at your other context clues. The fact that I saw a flagellate earlier moving around in here, that's a good sign. The fact that I see really good aggregation, the fact that I don't see a lot of other anaerobic material tells me that there's a lot of insisted protozoa in here because we're causing disturbance and not because the soil itself is not favorable. If we were to see ciliates moving really quickly through the field of view, that's the type of protozoa where we would go, oh, this might be moving towards anaerobic, but you would probably also be seeing oomycetes, actinobacteria, low aggregation, lactobacilli, stuff like that. So you'd have more than one clue as to whether that soil was anaerobic or not.